Great. And then, okay. So somebody's saying tuba. Okay, now somebody muted. That's great. So now I want to show you. Today I'm going to show. Let me increase my volume first. Make sure. Right. Hopefully it is increased now. Today I'm going to show you complete the Python code. And I want to complete that Python code for many things. I want to show you how usually tools are structured. Then I want to go to Jupyter Notebook. But maybe I should actually go to Jupyter Notebook first for a minute and show you what is coming. So even if we go in a rush towards the end, at least you would know what we would be doing and how to do. Hey Rajesh, hey Tom, I see. Let me show you what is a Jupyter Notebook, and then we'll get back to coding. I am sharing my screen, and I am going to show you. Right, this is my terminal window, this one. And I am running PyCharm. See, wherever I downloaded, I went to the bin and I typed PyCharm. And the whole IDE came up. And if I do control, let me see, okay, PyCharm. And if I do control, see, look, this is the PyCharm that's running. I can disconnect it by killing this command. Let's do that. Here, it's dead. Instead, what I'm going to show you is something. Anil, how is my voice? Is it clear, loud?
Yeah, it's clear and loud, yes.
Okay, great. I want to show you something that you can use to do calculations. We are data scientists. We are not going to always write code that is going to run in production, because we want to see some understand how things work, and so on. So we do a lot of scratch calculations. And there is a very good tool for that called Jupyter Notebook. It's a software in Ubuntu. You can install in Microsoft, you can install. It's essentially a local web server that can.
Kishori, can you please maximize this window? Terminal
Yes.
one.
Yes, I'm going to maximize that. Yeah. How is it now?
Yeah, it's better.
Okay. So now this Jupyter Notebook will work as a web server. And what it does, you can write something on a page and it goes to the compiler and then displays the results. Okay. So let me first show you what it is. I'm going to type Jupyter Notebook because it's already installed. It's very easy to install, and let me know if you need any help in installing. I'll send you instructions. But in YouTube, how to do Jupyter Notebook, how to use it, there are lots of tutorials, and that's where I learned. Here it's running in the background. Here is a web page that showed up. Looks like I have some notebooks here, Jupyter notebooks, and I'm going to actually start using them. Okay, so that is essentially a folder where I have Jupyter Notebook running. Let me terminate it. First, I have a folder where I have the notebooks. A notebook looks like this. They have this IPNYB. This is the extension for Jupyter Notebooks. And I'm going to show one notebook, which is a simple algorithm for generating random numbers. And whichever folder you are in, from there you type the command Jupyter Notebook so that the whole folder is visible from there. Let's do it again. Here I go. I can see everything. These are the notebooks. You see this symbol notebook? Neil, can you see my pointer? Mouse pointer.
Yes, I can. Yes, great. We can. Yes.
So these are the notebooks, and these are folders. I have some notebook inside. Shall we open one of the notebooks? Yes, let's do that. I opened too many of them. I didn't mean to. Let me close it. Yep. Let's go into this folder. Right, notebooks. Okay, so I am looking for something more interesting than that. Let us see. Intro, Python, data science. Okay, I think this is where I was looking at. Notebooks. Okay, I am looking for something called distributions. Okay, not here. Introduction to frequency distribution. Let me see. So these are my notebooks, and I want to open the right one for you so that it's directly shows. So, and I was actually doing some analysis, distribution plots for area-wise, a square kilometer area-wise, you know, of Indian states, different states, and that's what I want to show you now. So, where is my favorite notebook? Introduction to, let's see. Oh yeah, not this one. Intro to stats, descriptive implementation of backpropagation, perception. Okay, so this is how a Jupyter notebook. This is maybe not the right one. I want to show you a. Oh, these are not notebooks. These are notebooks. Okay, so this is how a notebook looks like. You can write comments. You can execute commands. But give me 1 second, and I'll find the right one for you. And it would. So I go to my Jupyter notebook, and then I do look for the file that has distributions. Okay, checkpoint distributions, and then frequency. Okay, so it's in the intro to stats, notebooks, and distributions. Intro to stats, notebooks, and distributions. And I want to show you distributions. Here is what I'm going to do now. These are, you will see as we write code today, these imports libraries. Here, you are importing a library called Panda. Data science relies with a lot of nice, what do I call it, libraries that are suitable for data manipulation. And one of them is called Panda and NumPy. You have to tell your employee, if you go for a job, you should say, I know NumPy, I know Panda. You'll see that they talk about it all the time. Panda and not. And let me show you about something about pandas. If you want to know anything about pandas, always Google search, and there is more information on panda. So there is a data frame, and it is a tabular data set you can manipulate programmatically. But let's see it as we go. NumPy is good for mathematical calculation. Seaborn is another library that is very suitable for plotting nice plots. And this is for random number generation. What you do in Jupyter Notebook, you see all of these nicely written pictures, plots, and this is code. There are two types of cells. These are all built-in cells as cells. This is text, and there is a way you can write this text, and you can write nice formula, plots, right? It's like HTML even, and you can even do calculations here. How do I do calculation? These cells, input. Let me show you how I do this calculation. So I click here and do Shift Enter. All it did is that it loaded into Python. Python has a shell. It's like you can do like an interactive way, not just like a regular, not only just like a regular software like we were showing yesterday, you can execute. Now, I want to do an experiment with you, okay? So let me stop sharing and go to the board. And there is an interesting thing. I want to. I will leave this part intact. Suppose you have a die, it has 6 faces. 1, 2, 3, and so on. So if you roll a die randomly, you will get up to any of these numbers, 6. So you roll first time, roll 1, randomly 1, next time you might get 3, next time you might get 4, then you might get 6, then you might get 3, again 2, and so on. And then let's plot it. How many you get? So I've 1, 2, 3, 4, 5, 6, 7. Let's look at how many I get of each. And this is going to lead us to probability distribution. Now, let's see how this is a number. 1, 2, 3, 4, and so on. How many ones I got? Oh, 1, I guess. 1. And then you got another 1. And you got 2 3s. So here you got bar. 4, you got 1 1. Great. 5, nothing. 0, 6, 1. Well, in a perfect world, okay, let's do 3 more, a few more. In a perfect world, you think if the die is very fair, you'd expect 1 6 1 6 1 6 of each. I think there is a question. Let me see. The voice is not clear. I see. I see. I know why. That is because. How is it, Neil? Can you hear my voice?
Yeah, it's better. It's better.
Okay, great.
Clear, actually, in between it got struck up. Yeah, it's clear now.
Okay, great. So thank you for bringing it up, Ravi. Okay, so in a perfect world, you expect everything to be 1/6. Did it happen here? Almost, maybe not. Well, this behavior of being able to repeat an experiment is at the heart of probability. The idea is that things you keep trying and certain things appear in certain proportions. Here, I believe they are of all equal proportion. That's why if you keep doing more and more, probably if you plot, they will not be like jumping up and down. And I want to show you how do I do a random coin toss here. So what I'm going to do, in most of the programming languages, you'll find something called rand function. I'm sure you have seen it, rand function. Let me switch marker. Rand 2. Rand function. A rand function, you can also specify what kind of random number you want. It's a number that comes up nowhere. You just specify a range or type. I'm going to generate random number between 1 and 6. And there is no bias. It's essentially a computer algorithm that keeps computing it takes the time, multiplies by some number, divides by some number, and then whatever is remaining, that kind of complicated thing. So it goes through a process. And that looks to you random. But there is no perfect randomness in computer. It is just a mathematical calculation. They do too many operations that you even lose track of what shows up at the end. So we generate random. So I'm going to generate a lot of random numbers between 1 and 6, actually including 1 and 6. And they are all uniform. What I expect when I plot, say I do 1,000 or say 600, say. In a perfect world, I would expect about 100 of them to be 1, 100 of them to be 2, and so on. That's what we expect, right? What I'm going to show you that they become more evenly distributed only if you have larger number. So 1200 will make it even more uniform. As you keep going to infinity, in the limit, it will be exactly equal. Of course, we will never reach there. All it says that it keeps going towards it. Let's do an experiment with Jupyter Notebook. So I have to. Okay, so here we go. We are in the Jupyter Notebook. Rn is a random number generator library. So I'm importing random. I really don't want to keep typing random everywhere. I give it a short name. It is called as. So you get random number and use Rn, a short form. Then I'm going to use function. There is a function called seed. Because random number is a mathematical calculation, it starts with some number and then does something crazy, all kinds of calculations to arrive at a random number. If you do not provide this seed, you will get different kinds of random number every time you do. But when you fix the seed, it is the same stream of random numbers you get. Why is it important? Because sometimes you want to reproduce your result to your boss. But if every time it changes, you may not see the issue that you are showing. Here, what I'm doing is that range is a function in Python that prints out in a list or an array the numbers from 0 to 36. Of course, you have to exclude 36. It's always one less. It's a for loop. It's just spinning. X is equal to 0, 1, 2, 3, 4, 5, 6, and so on until 36. So every time this array spins, it puts whatever is here into the array. This is called list comprehension. HRE, whatever, maybe there's a mistake in my spelling for comprehension. So every time you run this loop, what it calls is that from this random number library, it gets a random number between 0 and between 1 to 6, and it is stored in an array. So let me print out what you see here. Okay, and look at it. I'm not writing any code. This is not a debugger. This is not an IDE, but I can write calculation right on the notebook. What I do here, I go there to execute this box. I already executed this box, so it's like I have already done those lines. Now these lines, I do shift and enter. There are a lot of commands you can see online, but shift enter will. What did you see? You found 36 numbers, and each time there is a random number and it's an array list. You see, these are the ones. Okay. So let me now pause for a second and give you a chance to ask questions about this. It's something new. Neil?
Yes.
Do you have any question yourself? Or anyone else? I'm just using you as a moderator.
Kishori.
Oh, somebody. Yeah.
Yeah, Kishori. I didn't understand the seed. Seed is set to 12. So
Right.
is that and what's the difference between seed and the rand integer 1 to 6?
Great. Okay. So let me go to the board. It's important thing, and you should. Now, I'm going to remove this because you have seen this idea. So random number in a computer, how it's done is there are many algorithms. And one of the simplest algorithm you and I am going to create now, maybe it's not the best algorithm, but just as an example. So what we will do, we'll take some number, say 5. Our policy is that 5, we always multiply it by, for the first random number, you always generate one after another. Give me the first one, give me the second one, give me the third one. Let's the first one. This is our policy for the first one. Okay. First, go ahead. Somebody has a question.
Yeah, I got the random number, like it generates between that particular range, but what the seed is setting there as a 12?
I'm coming there.
I mean,
I'm coming to that.
Okay.
I'm coming to that.
Okay.
So yeah, so you take the initial number. Say I always multiply it by 10. Say I always add it by something. Say 3. Okay. So then what I do, because I am interested in between 1 and 6, so I take this number and do modulo 6, and whatever number comes out, I add 1 to it, so that it is, because modulo will sometimes give me between 0 to 5, but I want from 1 to 6, so I add 1 up. In this case, 5 times 50, 50 times 3, So that is 48 divided by 6, that it leaves you with 5, and that gives you 6 in this case. If you do the modulo, after adding 1, you will get actually 6. Then I take this number 6 to the second one, I do 6 as this number, and again 10 plus 3, 6. This time I get 63, modulo thing 3 plus 1, I get 4. So this is how I keep generating. Look at this. This remains fixed. This remains fixed. This is between 6. What is happening is that I start here, and this input comes here. Look at this. What if you had done 3? Why 3? It could be anything. It could be a system time, a number that comes from system time usually. But every time you generate this sequence, depending on the system time, you will get a different sequence. This is annoying. Every time you run, system time is different at that time, you will get a different sequence. But you're a data scientist, and you want to share your result with some of your friends because you want to see the same random sequence. It's random, but the same sequence. What you want here is fixed, not start with random time t, seed, rather a seed, so that you can control. So as long as this is fixed, even though it looks like random, but it's the same random sequence every time. This way you can control. Otherwise, if you say, hey, I got this data set randomly, I got this result, your boss will be like, can you show me again? If you do not use this seed and time, maybe the next data set, the problem is not there. So you run again, it's not there. So you fix your seed. So if you fix your seed, every time you get a very similar random number, same random distribution as you keep drawing. And that's why seed is used, so that you can fix your world, repeat your world. And in computer science or data science, you need to be able to repeat experiments. I mean, think about how many times in your production system, some errors sometimes appear, sometimes disappear. It's very hard. You want to be able to fix the behavior. Did it explain, Rupesh, what you're looking for? Or
Yeah, sorry. Actually, what I'm thinking, whether if we run this program again and again, that same kind of random number it will generate. Or
exactly. Reproducibility is very important.
Okay, sort of this way.
If we not
Say that again, Saurabh.
Yeah. So just want to know, there is specific rule through which we can determine which seed will be chosen, or any kind of.
Right. So in general, seed only helps you fix the sequence of, so that you can repeat it, but you cannot determine. The idea of randomness, because as you know, computer truly does not have anything random. It is always coming from a number. Maybe it's time, but still it's not random. It's essentially a computation going on, and it's fixed type. So if you could actually predict with a seed what random you are going to get, suppose you have come up with a great formula. It gives you random number. All you put is the which random number you want, it spits out the random number. If you ever have a formula, maybe somebody is very brilliant. Immediately, if you can write in a formula that can produce randomness, it is not random anymore. In computer science, it's called actually pseudo-random. No random, there is no perfect random number. It's called pseudo, partially random, almost random, not real random. The definition is that if you can compute, it's no more random. If you can predict, it's no more random. The definition of pseudo-randomness is, in some layman's language, is that there is infinite amount of, literally uncomputable amount of computation you have to do, be able to write this, determine what is this sequence actually. Say you are a great mathematician, you figured out and a great formula, and you can compute it fast, then it is not random. It has to do with the definition that to figure out with a seed what it will be, even if you have as many computers as there are particles in the universe, it will take the age of the universe to compute. So that's how it is defined actually. And there are a lot of mathematics behind it. It shows that with the current computers, you cannot compute certain random functions. You cannot reverse engineer.
Okay, so it's basically based on the expression or formula. We have to choose. We have to choose our seed, right?
Sure, yes. So you pick your seed, anything, and in fact, you can pick any seed. It just helps you reproduce the same exact random sequence. But it is very hard to tell, is this seed better than this seed? No, you can play around and whatever gives you the result, say you show that there is an error, you can reproduce it. So that
So we can say that by choosing a seed, we can come up with a proper expression that will give me a consistent result, right?
no, it will give you a reproducible result. Say you
Yeah.
give me an experiment, Monte Carlo, and you use some random random function, and you got the calculations. And you told me yesterday, Kishori, I got this result. It's strange. I see these strange results. And I'm like, can you give me the program? Let me run it. And if I don't fix the seed, I will not get the same sequence of random numbers. I may not be able to reproduce what you saw. If you fix the seed, at least it will generate the same sequence of randomness, and I should see what you are claiming or you are trying to communicate to me. It makes so that you can reproduce it. Say you see some behavior in some randomness calculation after a lot of simulation, and you want to share with me, and I run. If I don't fix this seed, maybe because anything that you use randomness, the results change from run to run. And it will keep jumping around. And I'm going to show you right now, without seed, what happens.
Okay.
Yeah.
Thank you.
Okay. So I'm going to share my screen. So this is what you got the numbers, random. Now I'm going to put it in a form. It's called dictionary. So you have used hash map, dictionary map. This is a key. This is the array. So I will show you how it looks. Print the data. Then I'm going to show you how to plot them. Let's plot it. Let's run it again, and I should see the results. See, I'm repeatedly able to run it, right? You see, this is the dictionary. It showed me that against this key, there is this array or list. That's all. Now I'm going to put it in a data frame. A data frame is a panda data frame. It's a special data frame, and you'll see. So a data frame is like a table, a panda table. I will show you how a panda table looks, but it has column names. Okay. So let me see online, how does a panda data frame look like? Here is one. I don't think I need to do it here. Here is one. So here it is creating a 2-column data. That's all it is doing. Actually, this is for 0, 1, 2, 3, but I will show you how a data frame looks like in Panda. Suppose you have a table. Let me create another one here. Say another random number generation here. Another sequence. This is called 2, and I call it nums, and I call it, put it in another, I call it res colon. It's like a tabular data, and I'm going to show you how it is. So let's see how this one looks like. What happened? This is like essentially a table. Table here and table here. Let me show on the board what it means. Panda is a library, and Panda has the concept of data frame. A data frame is like your table. Here it is. 0, 1, 2, 3, these are index. And this would be like, let me draw in a much bigger form. How would this I understand. I think people understood. I'm going to draw a data frame, how it's going to look like. A data frame in Pandas is tabular. Then you have column indexes, 0 or row index, 2, 3. It's like an Excel table. Say you have name, name. You have a bunch of names, same number, same number, same number. is same number, some number, float. It could be float, and this could be integer. Height maybe. I don't know. Year they were year now, whatever, year of first job. Like this. And it is like a variable. A data frame is like a variable. Let's call it df and panda data frame. It is actually called data frame. You use the function called panda library, PD, I call there in short. This is a short form because I do not want to keep typing pandas every time. That's why I imported it as import panda as PD. So this is my like short signature. There is a function called data frame. And I feed in the data. There is a syntax. This essentially, conceptually, this. So now you want to know the name, the series names. You type df dot this attribute name. So you see, even though you define in this data set this name, it is equivalent to essentially this whole series array. If you do df separately, df, this is the variable of the panda data frame. Whatever column name, put a dot. This is equivalent to this. So this is a very convenient way of being able to access tabular data, because as a data scientist, you'll be using it. And I'm going to show you an experiment now. So what I'm going to do random toss of 1 to 6, 600 times or 60 times. And I'm going to do the plot that I showed you, histogram it's called, the bar plot, and see what happens. So now share the screen. Okay, so this is the results because I added another column. It's just showing in a very, not a very nice way. But now I'm going to print only the results here. Let's look at the results here. I'm going to call it only results. And printing the results as you see here, this one, and I can do a dot, and this is the name of the variable I created, data frame. I call it create data frame. It's a panda data frame. See, PD, and this PD is here, PD, and the first line, and I call it pandas. Great. So which is nice. Now I want to plot. To plot, I use a library called Seaborn. I call it as SNS. See, look at this. I'm going to show you something. Instead of PD, I can call it also my panda. Same thing, it's my. This is exactly like I can type, because ideally if I did not put this, I'd have to type pandas. Some people don't like to type long names. Instead, they short define it. See, NP, NumPy, instead of NumPy. It makes their code clean. Nothing else. It does not make it faster. So let's see how the results look. Great. This is actually showing an error. Results. So what happened to this now? Maybe pandas is not defined, it says. Well, import pandas. PANDAS. Pandas is not defined, it says.
Yeah, Kishore, can you please increase the volume a bit? It's just getting
Yes.
low, actually.
Yes, now?
Yeah, it's better. Thank you.
Okay, sure. Create a data frame, print results, DF. It says pandas is not defined. Okay, as EN, let's say. This should work. Maybe there is small typo, but I'm not going to kind of, oh, I wrote PAN. It should be PN. So you can see the error message, what happens here, why it failed. And actually you can, oh, it says, oh, now I see why it is not able to define pandas. Okay. If you have any guess, let me know. Pan should work here. That is because I changed this code, but I did not execute this code to take into effect. That was, once you execute, it remembers the previous execution. So I have to execute it. Now I can do pandas. It will show the same result. There you go. See what you saw. Results, it's spitting out the whole number, all this. Now I'm going to display it on a screen. And I don't want this annoying displays. This is because this is cluttering up, you see, taking so many space. Instead, I am going to now comment it out and run it again. Nice. I would like to plot it. Forget about this printing out. We don't need this. So I don't want to see anything. Then I am going to show you the plot. Now I'm going to plot with Seaborn. So distribution plot, the results, and all the bins from 1 to 8. Actually 1 to 7, 8 because I want to look at like a square and no distribution. Let's see how it looks. Beautiful, see? How many did I run? 36. I think I'm not even using this data set, nums1. So I'll just remove this unnecessary. This is just to give you a demo that how to use different columns. We are fine with one column. Our goal is to see how a Ludo die behaves. Let's run it again. Same result, right? Let's remove the seed. What happens? It will be random every time. You see, it looks like this time. Let's run it again. Shape keeps changing, you see. Now, if you tell me that, hey, I saw this, I can't pinpoint. Every time I run, it's a different result. Now, that is why you need the seed.
Yeah, Kishore, one question like, what is the KD here in that?
You. If I understood correctly, correct me if I'm wrong. You are asking what is the area, right?
KD means in the code like plotting. You have done right. KD and beans also.
I see. So could you please? Beans. Beans are essentially telling you if I don't put beans, because it is a histogram, it does not know that I'm interested in 1, 2, 3, 4. I want to block them. So it is only to block them. Let's see, make them look like blocks. Otherwise, I will come to that. For now, assume that it's 1, 2, 3, 4, 5, and 6. So ideally, this 1 should be sitting right in the middle. 2 should be sitting right here. It's the axis that's being plotted. But that is a good question. What am I doing with these bins? And I will show you with another example nicely. So I think you got the idea now. Let's, instead of 36, let's do 12. What do we get? 12, only 12 experiments. Anything? Not so pretty. I didn't get anything on 6. I can show you here the proof. Look at, see, I didn't get any 6. See, I was able to reproduce because I have the seed fixed. Now I am able to do that. See, there is no 6. 3 4s. 3 here, another 5 4s. 1, 2, 3, 4, 5. So, and there are 2 1s, 1 and 2. 1 3s. Exact, 2 3s probably. Oh, here is 1 3 and here is 1 3. This is called a histogram. Right? So I think you can even put a title here. How do I put a title? Now the question is, how do I put a title? I do know how to put a title, and I was putting it yesterday. Okay, never mind. I'll show you next time how to put a title on the plot. That's not a very important thing now. You can find out on the internet. So now I want to increase it to maybe 24, double. This looks like this is not 1/6. People would say this is like ridiculous. Most of the time your random draw gives me more 4s and few 1s and no 6. That's not true. Let's make the 24. Got it, but still looks like 2 is not so common. Doesn't look like it's random 1/6. Let's make it double. Let's go in double numbers, binary, 32, 32. Does it do better? Not so good. Make it 64. Yeah, getting better. Let's make it 500 or 600. Much better, see? But still there is unevenness. But proportion-wise, they are almost getting there, equal. So 6,000. What about 6,000? I don't want to print 6,000 numbers, so I'll comment this out because these were the 600 numbers you saw. This is almost there, you see? This is the idea of probability. The more experiments you do, the more proportionally this shows up as a distribution. Like it is, you can also call it distribution. See, I made it 60,000. So the more you do, better the result gets uniformly. There is no other, kind of, this is called histogram. It is here, it's uniform. And you can create different proportions. Maybe you want to produce 4 more times than others. And there is a way to do that. And I will show you. But let me stop here and ask you a question. Ask you, not question, give you a chance to ask questions. Neil, do you want to moderate it?
Yes, I think participants has questions, I guess. Yeah, feel free to raise questions anyone has.
Yeah, hello.
Mm-hmm.
Yeah, Kishori. So if you said KD is true, what it will happen?
Right. KD is true is essentially it tries to fit a distribution. How the shape looks like. Let me go there. Stop sharing the screen. And I'm going to show you. So essentially what happens when you do a plot like this, let's stick with the Ludo 5, 6. Suppose somehow 2 is more abundant because not some Ludo die could be, skewed, maybe not uniform, maybe somebody manipulated it, right? Look at this. There is a shape, right? It kind of tries to tell you the shape actually, how this looks like approximately. This is called kernel density estimate. Kernel density estimate, KDE. So if I do that, there will be a curve like that probably. I have not tried it, I can try, and we will do that in the next immediate 5 minutes actually. So any other question about it?
And one more question is, you define MATLAB inline object is, what is that object?
Oh, so that is coming from the Seaborn library. So that object helps you make this plot, the picture, things that you can draw on it and plot on it. Object. So, and this is why you see, you are using a notebook, you are writing your comments. I'll show you how to write comments separately as well as the code. There are 2 kinds of blocks you see in the Jupyter notebook. You can write comment type block or executable code type block. Whatever you execute in the code shows up right below it. Then you can write comment as many times. You can interleave them in any way you want. Maybe it's a bunch of comments. The whole notebook is written this way. So what it does in the Jupyter notebook, they interact with Python, and that object is suitable for, that's a library that creates object for drawing on the screen, and it puts it into the notebook. Yeah, any other question? Any question? This is, I know it may be new for many people. Feel free to ask any kind of question.
Sure, you want to ask one question. Can you able to hear me? Hello?
Yes, yeah.
Yeah, okay. So I want to know what we have tried to achieve with this of doing this program, and by putting those random values from low to high. So is it not hard coded? I mean, what we are trying to achieve with this thing? I didn't get that point.
Yeah. So sometimes, so this has 2 purposes. One is to show you about probability something, that there is a concept of distribution, and you keep drawing more and more random trials, there is a limit it goes to, a shape. In our case, because the die was even, it's like a uniform. So the point is that when you talk about random trials, if the more you do trial, the more you get the shape. Suppose in India, there is an election coming and we are interested in the Prime Minister's popularity. What percent of Indians think he's a great Prime Minister? How many thinks they are is not so great? What would you do as a newspaper agent or news journalist? You will randomly ask some people. You cannot ask 1.2 billion people a survey. You need a representative. So the representation is going to come from no, my drawing is not so good. Leave some room for Nepal and Bhutan. Okay. This is Orissa. Okay. Lakshadweep. Okay. So you are going to probably randomly pick some people. Suppose you have the phone numbers of all the people or many people. You are randomly going to sample and you are going to talk about it's a countrywide election, right? How are you going to pick it? Are you going to pick someone who favors the result? No, you are going to pick randomly. And that's where you need randomness, who to pick randomly. Now, how many should you pick? 5 guys and tell the results? No. The more you pick results randomly, more you are going to get the actual distribution. So that is the point of random sampling. That we'll need it for random sampling. Many of the machine learning algorithms, yesterday you saw, you cannot get every data point in the world. You have to sample it so that you can check. And that is the idea.
Okay, thank you.
Yeah, that is important. That's a very good question. Now, what I'm going to do is a real demo to see what I'm trying to look at. All the union territories and states of India. I'm going to download a little file, copy and paste from the internet, state-wise, square area, square kilometer. The whole country, if you sum them all, it's the sum of whole country square kilometer area, assuming. And I'm going to plot a distribution, how it looks. Do they look, smaller states are more or bigger states are more, like this kind of distribution? I don't know. So let's try that. Sorry, now let me share the screen. Share the screen. Great. So what I'm going to do is that download some data from the internet. So I'm going to share my screen where I download what I'm doing it. I went to a website. Where is my website? Let me show you my website. Okay. Somewhere online, I went to India by, Indian by state. So I will not, so essentially I copied and pasted this. I just copied and pasted this square kilometer, you see? So I need maybe, this is the number, these are union territories, and this is the name of the state. And this is the number in square kilometer. This is in mile, square mile. I don't care. I don't know about these. It's probably comparing whatever. I need to clean the data. Okay. Let's clean it. How do we do that? I have already cleaned it for you. Let me show you how it looks. First, I call number, state, area. But how do I clean it? That is very important. And I want to show you the usefulness of Linux here. Let's start this. Let's skip this file aside. Call it indian.txt backup. But I need to create a indian.txt. Okay. Here you see two files. State, India. So I'm going to do is cat. I'm a data scientist. I don't care. I want to get the data out. Okay, I know that there is a tab and I know there is a 3 column and this shows up. Here is what I'm going to do. Concatenate. This is so important in Linux. This is why we use. Awk is a command line program, a program that you can use in command line. So it says that F means field separator, separated by tab. Okay, the first one. When I separate it, what am I going to get? 1, 2, 3, 4 like this. Second one would be Rajasthan, Madhya Pradesh, the second column. Let's see what I get. Oh, I got this. Great. What if I do 2? Oh, it only gives me the name of the state. What about 3? Yeah, this is what I need, but I don't need the comma. It's distracting. Let's see now how I format this file. Again, I would like to have in the first column number. I call it number. That is a string. Dollar means the variable number, the column number. And this is a program that processes line by line. One line comes, it applies this and gives you. So whichever line comes first, this is going to, no, I'm sorry. This tab, and I want to put $2. So it is going to put the first column value, second column value, and third column value. Is it useful? No, if everything is stuck together, it's not useful. Well, here is what I can do. I want tab. Tab is a string, put it in this format. Double quote. Some of you might not have seen it, that's why I'm doing it for you. So see, looks better. Now I'm going to do put another tab in between. That looks much more like a string. I don't want the commas. It's annoying. I want to remove. The set is a stream editor. It can substitute. I'm going to substitute it. Substitute, it's an edit command. Like the VI, those who use VI, substitute first / and it says, I want to substitute comma with nothing. That's why slash. These slashes are like partitions to show globally through the entire string. What happened? A beautiful thing came out, right? Now I need to put it in a file called, let's call it Indian. You know what? I would like to also add a few things. I call it number, first line. I call it state. I call it area. This extra line. Look at this now. Let's type. Great. This is a nice data set. Let's load it. So let's go to Jupyter Notebook and load this file in pandas. Here. So you can do pandas. We know that in this we have executed this. So I have this library loaded. Oh, it's called pandas now. Here I'm using PD. I better make sure I want to call it PD unless I want to change it as PD. Let's call it PD. But then I have to change it back if I want to do PD. Let's make sure we execute it. Let's make sure this works. This doesn't matter. We are not doing calculation. We are not interested in this. So here in my folder, I'm inside some folder and I want to load the data folder. That's all I'm doing. .out. I don't know where my data folder is. First I have to see. Oh, Jupyter data. So from the home directory straight, I have to be careful. Okay. So it's because this notebook is hidden two levels below. So I have to relative position of this file. And I know that the separator is tab. So now I want to show you what happens if I load this. Let's comment this out now.
Hi, Kishori.
Yeah, sure.
I have a doubt.
Yes.
Here in pandas, you are using CSV, right? But you are importing text file. Will this support?
It is the function name is called read CSV, but you can use any separator. That's why I am separating here with tab. You see, tab.
Okay.
Yeah, but the function name is CSV. It can do comma separated as well as any tab any separated. You have to specify the SEP if you don't want it to be comma. You say that it is a tab. Treat them like tab. because my function is in tab. Here the separation is in tab. Did I answer your question?
Yeah.
Okay, great. So now let's look at what did I load here. I loaded some data and it directly makes it a panda thing. Print state data. I don't know what I'm going to get. Let's see. I'm a little worried. Oh, wow. The whole thing came out. And I'm interested in state only, say. Put dot state. Great. This is just index 1, 2, 3, 4, 5 like that. Okay. So that looks great to me.
Right.
What I want.
Yeah, sorry, I have a question here.
Yes.
Let's say you have an unstructured data in an Excel file. Okay, so this data that you are displaying it, you are taking it from some .txt file or .csv file. So let's say you have some other format and you want to directly kind of take the data from that Excel file and you do the manipulation here or whatever way in the column wise or in row wise you want to see. So you can do all this manipulation here on the Jupyter Notebook. Is that correct?
Yes, except if you want to use Excel, you have to use the Excel library to read it in. A library, Panda can read text files. Maybe Panda has a support to read directly Excel file. So it depends if there is a library or not. If there is no library, maybe you will have to write one. If there is, you can use. One way is that, let's see, Google. You should always use Google. Data science is not about memorizing. When I was doing Linux, Unix, a lot of our students used to memorize, oh, I know these many commands in Unix. You should know some basic commands, but you should not try to memorize everything. It's a waste of time if you have Google. Well, if you don't have Google, if you don't have internet, well, then do you really want to do data science? This is a more of a subject of internet and computing. So anyhow, pandas can export from Excel. Let's see, is there anything? Does it support? Yeah, looks like maybe some guys have some to Excel function, maybe. Does it answer your question, Neil?
Yes, just addition to that question that let's say if the data are very messy, it's not in a very structured format. So is there any way that we can structure it in the Jupyter Notebook itself?
Structured data, unstructured data is always unstructured. How you structure is up to you. So there is no formula for manipulating unstructured data because unstructured data could be an image, a movie, a story. It can be anything. So you have to write your unstructured. So unstructured data, it means it's not very tabular, essentially. Unstructured data is like unlimited. It's like, say, ask me a question that I don't know. There are too many of them. So you cannot have a mechanism to answer all the questions in the world. So unstructured data, it always needs massaging. Just like I downloaded from the internet, right? This data I copied, pasted, I made it structured. There is true unstructured data cannot be learned easily unless by deep learning method, and they will not be very accurate.
Okay.
Yeah, so it's like saying that, yeah, unstructured data, you always have to transform in some way. Yes, if you see the same pattern, for example, Facebook comments, then you can write a library that exploits that Facebook's pattern, but it cannot do everything. It can only do Facebook. It will not say, download all the books by Arundhati Rai and then make a nice table for you, because unstructured is unlimited. You have to make it structured. But tabular data is structured, and that's why there is a fixed form. So now I want to show you another thing.
Hi, Kishori.
Yeah, go ahead.
There is any limit of number of record we can load into the NumPy?
You can go millions of them, as much as your RAM supports, essentially. You may not be able to print it out on Jupyter Notebook. It will. There is a limit how much it's willing to print, but you can load millions of them.
Okay.
Yeah, it's for real serious work. It can even connect from a remote database and then pull the data, make queries. And it itself, you can make queries in pandas. NumPy also same thing, but it's not more into queries. Okay, so let's say area I'm going to print. Numbers. Think about it. 3, 2, 4, 9. These are just ASCII symbols. This could as well be a string. I don't know how NumPy read it. It thought it's a string or not. So I want to make sure to interpret them as numbers. You see, I'm going to sum, take the state, area, and as type, you can convert on the fly into integer. Let's see what happens and print it, the sum. Oh, it printed this at the end, it printed this value. So it's sum. So I converted it into. Let's see if it has other forms, because it could be string as well. String cannot be added, right? You cannot sum a string. Float. Float is real numbers. Maybe it can interpret. I don't know. Yeah, it reaches a float. I guess it should be a float. Right. Now, I want to plot this distribution. How does it look? What is this bin? What is this KDE? We'll come to that area. Oh, I should not print this. It is printed this, yeah, okay. So I'm going to show. You see, this is what you are getting. There are some states. All I am doing is that these blocks are each 100,000 square kilometer blocks. And the maximum is up to 350. That I did because I think the highest state has that many number, if I remember correctly. No, this is not. I think the largest area is this. Yeah, 342, so I made it more a little. I could do even max, you know, I could, instead of typing, I could say max of this, automatically take it. Max of, it can compute state, area as type, float, max, plus maybe 100,000. I'm just adding it 100, just to make, so there is room. So there is no rule as such, whatever makes it reasonably good. So yeah, state as type. So area, it did not interpret that. Oh, this is a vector, right? So yeah, so maybe max doesn't exist here. So we'll have to see. I want to compute the max of this whole thing.
Yeah, hi, Kishori.
Yes.
Typo.
You have to give state data instead of state. Hello.
Oh, yeah,
So
yeah, you are right. State data. Yes. Let's see. Yes. So thank you. Let's see. What else did I make mistake? Integer, range, integer and argument expected got float. Okay, sure. I'll give him as integer. Maybe this function likes only, you know. Yeah. Yes. Thank you. See, I just added this. Okay. This is so good. So why is it looking like that? What about the bins? Bins are how wide you want to lump them together. Let's see what happened. I made that each bin consider two states in two groups if they are like defined by 100,000. What if I lump them together? I reduce, this is saying range is 0 to here and in bin size of buckets of this. So if it is like 2 and if it is 0 to say million, it will go as 0, 2, 4, 6, so on. If it is 1,000, this should go like 0, 1,000, 2,000, 3,000. Or if it is like say 500, it would go as 0, 500, 1,000, so on. This is the step size. That's what determines these plots. You see, I'm going to do on the same plot a different size, a different bin size. What do I get? Make it bigger. Put them together as histogram, right? Count them together 5 times. What do I get? Oh, what happened here? He did. You see, these actual ones are here. One is how much? 9. All these guys got together. So if you sum them up, this is 9 plus 2 plus 11, 11 plus 3, I don't know, 14, and then these 2, 1, 1 became 16. So it became a bigger bucket, you see? This is the histogram. It is a better shape, right? And if I make it even bigger, So that means this histogram, it depends how many data points you have. If you have too few data points, it looks ugly. It's very hard to see a continuous. Now you are seeing a shape. Hey, let's run it again with your KDE on. What do I get? True. Can you give me a pattern how it might look? Wow, it did not for some reason. True. Let me make this thing like this, KDE. That give an estimate, right? So it thinks that, you know, probably if you have similar India-like country, did a lot of experiments, this is probably it would look like. You know, this is a false, this is a lie. There is no state that can have negative area. You see? That's a lie. It should like this. So there is a way to say that, well, this is the range. Don't look beyond that. I can actually fix the range of this KDE. That area cannot be negative. You have to tell it. A model doesn't know. Here it thinks that negative, positive. It just looks at the trend. He thinks, oh yeah, I think it should come down. It's just an interpolation. This is not exact. This is all a part of data manipulation or thinking. So if you want to see, restrict it to positive, I don't know. I have not done it actually. Let's see this plot, Seaborn. This is the actual name of the library, right? Seaborn. And I want to say KDE specify range. I'm going to do a Google search just to show you how I do. This plot, Seaborn, KDE non-negative range. This is how you Google search and figure out. Oh, lower bound to kernel density. Oh, okay, great. I have a collection of measured 3 parameters trying to plot a histogram with this. The Seaborn module lets me, okay. But he doesn't need, should be 0 for negative numbers. Oh, what do you do? Oh, KDE, rug, I guess so. You do set limit. Here is the function, x limit. There is a way to force the density estimate to 0, that function, but you can always the access limits so that the left. This is not a good answer. This is just limit manipulation. There must be some way, KDE, that we have to look or think or may not exist. Maybe you will write a tool that is a better KDE estimation. Maybe KDE is a kernel density. It always has naturally the negative. Maybe you need an estimation that handles only positive. So, right. So that is the idea I wanted to show you about Jupyter Notebooks. So this is not necessarily correct. You need some density estimator. These are called density estimator that is suitable from only 0 to positive. And is there a library? You have to search. Is it always going to be accurate? No, it is just a statistical interpolation fit. But it looks more or less kind of acceptable. As you sample more data, this will become more accurate. So as we are coming to the end, I wanted to do Python more, but I think if I do Python now and complete it, it will be a rush. So I think we should spend time, ask questions here and discuss this more to make sure people know about Jupyter Notebook, what I did. So why don't you guys start discussing for the next 12 minutes we have?
Kishore, can you just go back to the your Blackboard, and can you explain that concept of the probability, that distribution, why it's coming and where it is coming from? Probably the underlying maths, the statistics on that. Probably that will give more clarity.
Let me give an idea about probability distributions. I will come to a idea about distribution. Say somebody is asking you, how much does an IT person earn in some city? So what you do, you go around doing a survey. From the survey, you say IT professional 1, 17 lakhs, IT professional 2, 15 lakhs, IT professional 3, 14 lakhs, IT professional 4, 15 lakhs, and so on and on. Now you create what I call histograms, how many you found. So you look at 0, you know, maybe 5, 10, 15, 12, 25, 30, and so on. So if you look at it, you'll always find some relative numbers. Maybe most of the people are earning 15K, maybe, or maybe 20K is the more, depends, or maybe less, right? This is what you would expect. The beginners, they start, maybe a lot of beginners actually, much lower sometimes, and it goes up and goes up and goes up. Fewer senior people and goes down. This spread of behavior, what is this? This is the salary amount. And this is what? Number of people. This is the symbol I use for number, has, you know, probably, number of people. You got this spread. The more people you collect, the finer it will be, the shape will be better. Let me remove this and show you what would happen if you increase double the number of people you sample. I'm keeping the same scale. I'm keep here. Numbers are same. If you double the number list, most likely you are going to get everything a little bit double, right? This will be also, everything will be double height. I don't know, this will be, just trying to see, maybe double height, a little height, and peak in the middle, double peak. I don't know, it's double or triple, but the shape is there. Shape is there. The more you do sample, the more also it will be finer, more reliable data is. This shape, when you normalize it, as if you have 1% fraction in terms of fraction between 0 and 1. So that's, now if you sum them all up, say you did 2,000, you will be 2,000 people, because this is the number of people. And this is say 1,000 people. If you sum all these values, height of these columns, you will end up with 1,000. Here is 2,000. We can assume that, what if it is all adds up to 1? You just divide these numbers by 2,000. And that will take you, create this kind of a shape. As if there was 1, but you nicely divide it. So divide all of these columns, you'll get maybe some value, small maybe. Small, and this will be maybe, I don't know, 0.5 or maybe 0.4. This will be maybe 0.2. But when you add this height of these columns at different salaries, the ranges, these do not change. 10, 15, 20, 25, 30, and so on. So this, the shape remains. If you add it up, because they will be stuck to one another, contiguous, there is no space. This area under that will also be equal, right, to 1. Essentially, it's adding up these strips. So let me explain that a little bit more carefully. So just let me ask people if they are, have any question on this.
Any questions?
Okay, good. So okay, no questions. No question doesn't mean it's good. Ask. I just said that you should have questions. So now let me draw that nicely and show you. So Neil, did you get the idea? What I'm trying to draw yourself?
Yes.
Okay.
Yes.
So now I'm going to draw nicely, a little bit more nicely, and I'm going to show you what I mean by that. Focus on this. Everything adds up to 1. Instead of 2,000, 3,000, this is called normalizing, as if there is 1. So, yes, there is a question.
Okay,
Okay, no question. Let's draw it nicely here so that the columns are right next to each other. This one. Then the next one is this one. The next one is this little taller. The next one is taller. Neil, can you see me?
Yes, I can see you.
Okay, I want to make sure this is very important. This is what? This is essentially distribution, at least, and this is from 0 to say whatever 5 lakh. Let's give them numbers. And then this is the value. The value is this. This is a middle point. I call it X, X1, X2, X3, X4, X5, X6, X7, X8, X9, the middle points. Right? These are the x-axis. These are salary. This is the number of people, frequency or fraction, percentage in decimal systems. And let's call that number fx. Just to say, whatever you have here, this value I call it fx. This is the percentage. So this tells you, this function, for this salary, middle point, what is the fraction of people is making that salary? Of course, we know all our salaries are here. And we have normalized it like divided by 2000 or 1000 depending on the data set. So if you write like this, fx2, all the way to fx, I think 9, if you add them up, all the fractions, what would you get? 1, 100%. That's all. So a distribution, this f, the shape, is called a distribution when it is continuously taken. If these things are smaller and smaller. But to do smaller and smaller, you need more and more data. So that is the idea of a distribution. How things are distributed or distribution.
Okay, and another, yeah, I think another question many of us would have that why need to use that Jupyter notebook instead of the PyCharm? Can you not do the same calculation, all these manipulations in the PyCharm instead of the Jupyter framework, Jupyter notebook?
You can. You have to keep running the same code, debug mode constantly. But this is easy. This is quick and dirty. Running a software in a IDE is time consuming. It's very hard to explain. It's hard to mail it to someone. Somebody has to install, and you cannot do remotely. That is the advantage. And I can write notes in the code. Can you write notes like that where I have all those? I'll show you here in a second. This is easy for communicating ideas. Let me show this. Look, I can write comments. I can explain something here. I can say, okay, I can go and say, I can insert a cell above. Okay, cell above, and I want to make it to say markdown type. Let's see how I convert it. Cell type, markdown. Okay. This is an example for showing the probability distribution of a die. So look at this. Nice comment. I can write anything. Then I can say the function the function I can write matlib e raised to the power minus x squared. Look at this, how beautifully I wrote the function. This, or I can do integration. Int a to b. I go there. This is going to see. Do you see that now? Their utility. Neil?
Yes, that's a very good feature actually.
Okay, so this way you can add plots, images. It's like a magic notebook. You can try out ideas quickly. Not everything has to do in production system. In production system, it's very difficult to debug. First, the data scientist idea it has to generate. You have to generate the idea. Then you do like a run in production system and write regression test and all. But as a data scientist, you work with idea. What about Spider? Yes, that is also another way you can use it. I chose Jupyter. These are all different alternatives, yes. Any other question? So I think we are soon coming to.
So, sorry, you were saying like in production system we are going to use PyCharm, and for normal system we are going to use like.
Oh
remote.
yes, in production system you'll directly use the Python interpreter. PyCharm is more of a IDE to develop the code.
So, so for personal things like if you want to generate some idea or for on desktop, then we use Jupyter or something.
Yes. Or say you did something, then you can mail me the Jupyter notebook and I can do the same calculation and write more comments. Yeah. It's like a notebook. I look at it as a magic notebook. In the same notebook, you can write program, execute, see the results. It's very beautiful.
And one more question, like sorry, that you are doing for data cleaning that has only 30 and 40 records.
Mm-hmm.
So if it is more records in millions of records, so how we are going to
right.
clean the
So
data?
the tool I use, awk and sad, I can do easily 100 million records.
Which tool?
The tool I use, you saw the Unix command line I use.
Yeah.
They are command line tools, so I can do millions of records like that, and just direct it to a file. So like the regular Linux system, direct the file arrow. You can do millions of records. It's not limited to like 50 or 60. It's very powerful, and that's one of the reasons why I'm advocating, which is the industry standard, that you use adopt Linux. Your life will be very easy and quick. Easy. Mm-hmm. Excel is not for millions of rows. Only recently it can support beyond 66,000, but it's not for heavy duty calculations. Any other questions?
And Kishore,
Yeah.
you explained about the negative index values. So in which scenario the negative index values will come, and how can we solve? How can we
Right.
overcome the negative index value? Like.
Right. The negative. Oh yeah, our values were negative counts, right? Like there are no state with a negative square area, and it showed 0. Most of the time, by default, the software thinks numbers are from negative to positive. So in order to overcome, you can perhaps set the limit hard, the hard limit, set limit 0 to thing, but that's a solution. But there is no one solution for that. There are many solutions. Different people will think differently. The most interesting part is that how you thought this is how the curve should look like. That's called density estimation or kind of extrapolation, right? If somebody gives you a survey data which is not complete and you yet want to make a statement, say you did not get any data about Madhya Pradesh. You can say, well, on an average, this is what I think for the country. Maybe Madhya Pradesh is also there, but maybe Madhya Pradesh is not a good representative of the everything. But that is a proxy, and data science is sometimes often an art actually. It is not like a hard and fast rule because you do not know what the truth is. It is just the best estimate.
So is it good to have So is it good to have the negative index value or not?
In this case, you can set the limit to 0. It is not a good idea. It's not a good or bad. You have to see, does the negative value make sense or not? Say, for example, if you say my distribution is about A's, negative value would not make sense. But if you say it's about some other temperature in Fahrenheit, yeah, it will make sense, negative value. So it depends on the scale and object you are measuring.
But
like in Excel, go ahead.
Yeah, but you did in the program, you started with 0, right? But why the negative values are coming?
Oh, I did. Yes. So that is the software KDE thinks that KDE is called kernel density estimate, and it uses Gaussian normal density. Gaussian normals naturally have negative values. Gaussians are used, kernel density is because its shape is very natural. But when you deal with negative, I think do not want to do negative, you have to take a distribution where negative value do not apply. So we should use something else. But unfortunately, in data science, as in many fields, not everything is done research. People are working on it. There are some people who are inventing new things. Maybe if you invent something or I invent something, that would be better. But not everything is available. And that is why data scientists need to make judgment. Oh, maybe this doesn't make sense, negative. Is there a library somebody wrote? Can I get it? Or can I talk to another data scientist, maybe who he does research on it? those are the cases you'll have to worry about. There is, again, for example, when you make a SQL query, there is no doubt about it. It's a SQL query. In data science, you are applying mathematics, computing, statistics, everything together. And there is no one way. So that is your decision. You have to justify. And that's why data science is in demand. A lot of IT things that we saw before, they were all one thing, software is available. There is one way of doing it. But data science, because everything is case by case, that's why there are so many data science jobs. Did it explain?
Yeah. Go.
Yeah.
We have one more question from Rabi. You can see the screen.
Oh, can the scenario revenue of companies profit require a negative index? It might, if you want to represent it. For example, Excel, if you want to put, some companies use negative, right? If you have a debt, profit positive. So that is your, whoever is providing you data. So one thing I would say that as data scientists, you are in a free world. Nobody is going to easily tell you this is the right way or that is the wrong way. And this is where you have to think independently. I know that in other systems, Java, Python, programming, IT systems, you are told, do this. This is the right way. This is Google standard of coding. This is it. There is no two way most of the time because things has advanced. Data science is so new that even if you did negative on something, maybe somebody will figure out, they'll say, hey, I don't think you should use negative. But there is nothing called, my God, it's so wrong. Like SQL query, if you don't write it, if it does not produce the same result, it's wrong outright, right? But in data science, it's up to you, a lot of things. And that's why you have to think independently, not rigidly, and more independently, ask questions like you are asking.
Hi, Kishori. For plotting, we did this for, suppose it's like X and Y, right? If it is three-dimensional, we cannot use this for plotting, right?
No, you cannot.
So,
go ahead.
Yeah, so what is that you use for plotting a three-dimensional?
Right. So three-dimensional, you can plot actually. You can rotate it around. I will show you. But for most of the part, you should not, and interactively you can rotate, but you should not focus too much on three-dimensional. Most data scientists do not use three-dimensional. Why? Three-dimensional is not visible to the interpretable. Human beings cannot see. So then you might say, does it mean that data science only solves problems that are two-dimension or one-dimension? No, they can solve problems that have millions of dimensions. But when you plot, you have to find a way to represent it. Representing is essentially in a way that it can be seen in a two-dimension. And there are methods that we will talk about it. But you should not go to three-dimension unless you are designing aircraft, modeling, CAD, CAM, they need. But data scientists may use three-dimension. There are some libraries, but it's not advisable. This is not something human beings can quickly interpret. You cannot go to your CEO and show a 3D picture and say, interpret this. He will be like, what nonsense. So that's something you should think, yeah. Other question?
One question, whether that data cleaning part. So in data cleaning part, whether that Panda data frame, that one support for XML on JSON file as well for semi-structured data.
I don't know if there are XML, but you can always import libraries that are XML parsers in Python, and you have to write some code maybe and get it to the format. But there is no direct XML to Panda. Maybe it depends on the data, but you may have to do some coding to write some code to get to that format.
Okay.
Mm-hmm. Any other question?
Yeah, you install the library pandas and numpy. Do we need to install using pip? We are installing the library, or it's built-in for built-in library?
My laptop, yeah, one laptop is going down on battery. I need to. So yes, you have to install the libraries on your machine, and I will show you how to install libraries. Ask me questions, send me emails, and I'll send you links. In Ubuntu, if you want to install a library, it's extremely easy. Say if you want to install in Ubuntu, you type pip. Pip is for Python libraries. Install pandas. So of course you can Google search it and you'll find it. But the idea is that this is it. In Windows, you have to download. You have to get 64-bit or 32-bit. Download from here, there. In Ubuntu, you type this and it's installed. Why is it so easy in install? Because most developers who develop these systems, they worked a lot on Linux systems. And they made life easy. And that's why I'm encouraging you to not buy any software, use everything open source. If you lose a job in one or leave a job in one place, go to a library, let's say laboratory in Germany, you cannot go around saying, hey, those software, can you buy it? I used to use in India, I like it. That's what I know. They're not going to buy it right away just because you want it. That's why you should use open source software. It makes your life easy. They're maintained. There is a lot of information. If you do a Google search on some software few guys use, you will not find any answers. So this is a survival tactic. Make your life easy. And these libraries, these are expensive because data science can take you anywhere in the world. You might be working at a medical company, genomics company, finance company, you have no idea. And jobs are everywhere. Any other question?
Yeah, hello.
Yeah, go ahead.
Yeah, suppose if I have a negative index value, but I don't want to show in the diagram, can we have an option to hide the negative index value?
Yes. Remember we were doing a Google search, how to, and they say the set X limit to this, and it will not show that X level. So in the plot, there was a Google search I was reading, and I didn't use it. It says set X range equal to, I think it's from 0 to something it's showing. This will cut it off. Those are all Google search. You can do Google search, and different people will have different ways. But there is always usually an answer. So as a data scientist, you don't have to worry about there is only one method. Whatever works, as long as there is a method, somebody wrote it, some library, your goal is still the data, not production system. Did it answer? Yeah.
Yeah, Kishori, one question. So like before feeding a file to Jupyter, we need to structure the data, right? In a proper format we need it.
There are quite a few structures this Panda library can hold. Excel, text. Yes, you should do go ahead.
Yeah, we cannot like randomly upload any file, kind of data file.
No,
so,
because it does not do it randomly. It does not understand.
Okay, so we like we separate out with the tabs, and then we reading that file in Jupyter and giving a separator as a tab. So that means like Jupyter is understanding, like it automatically form those keys, right? State, name, area.
Oh, that I added. The first line it takes is as a column name. Yes.
So basically that's what the sign, like, I mean, that was the separator which we are using reading that file as a tab. So it automatically use that separator as a tab to give the keys of those, right?
Right. Yes. Yes.
And by that, and so that's the important thing. If you remove the separator, it won't work that way.
Yes, if you remove the separator, it will treat everything like one column, because by default it, I think, takes comma as the separator.
Okay. So means, yeah, okay, got it.
Yeah.
Got it. Yeah.
So,
thank you.
And also remember, when you do this kind of data processing, you are a data scientist. You are not a support that does only thousands and thousands of same thing. That's why a lot of things, you get it, you put it in the format, get it working, because your goal is still to understand the concepts, not maintain. And that's why we do things like that. Data will be in different formats. Some of them will be easy to convert to the standard format, some are not. So we are in the Wild West.
Okay, so we have to organize it based on our requirement and
Yes,
what
yes.
output we needed.
Yes,
Yeah, got it.
absolutely. Yeah.
Yeah.
So in data science, you have to think freely everything, not rigidly. This is something I will communicate over time in the class. Any other question?
Okay.
Hi Kishore, Kishore of this side.
Yes.
So you are telling that only organized data you can plot in a data science, right?
No, you have to either organize it somehow. Yes, to get to plotting, because these plotting libraries take very straightforward tabular data set. Yes.
Yeah, so somewhere there is, as Neil mentioned, there is a unstructured data. So first we have to streamline those unstructured data as much as possible. Then
Yes.
we can import and plot into a
Absolutely.
panda libraries, right?
Absolutely.
So that is the standard we follow for the data science, right?
Absolutely. And that is for bioinformatics, finance, everywhere. It is always only the people, those who do say ETL or maintenance, they don't have to deal with it. But all the people who are facing the real problem in the business, they all have to go through it. And you have to make decisions on it. This is the right way I should store data. This is the right way we should change. That is a part of your wisdom as well as a data scientist.
Okay, and just one curiosity. So for the unstructured data, are we going to formalize any kind of expression so that we can structure it more better and put it into a diamond plotting?
That would be data dependent. For example, Facebook has a structure, right? I can explain. There is an image, there is these tabs. I know that it's more or less. Maybe the number of wall posts can be different, but there is a general structure. So not every structure can be mathematically formalized. I can give you a crazy structure. It will defy any formalism, all random, right? So as a data scientist, this is your creativity you will have to use, how to formalize it in the right way. And sometimes some data cannot be formalized, right, easily. Because if they are too random, too crazy, that is not something you can do. You have to get a data cleaner. But if you can, using some tricks, programming, yeah, it's great. So there is an open-ended question that is.
Okay, got it. Thank you.
So that's why I'm emphasizing Learn Linux. Those tools will help you. You see how quickly I could get the data, remove the comma, all these things. And I could do it in millions of files because I can do shell scripting in a minute. Yeah.
Okay, thank you.
Okay. So we are coming to an end. So what I'm thinking is that in this course, we'll give you this Jupyter notebook to play with in the week. And we'll have on Saturdays, I'll cover 2 topics always, 2 solid topics. And then we'll try to keep half an hour for this kind of discussion. This is what is going to make you learn.
Yep.
Any other question? Yeah, go ahead, please.
No, it's okay, fine.
Yeah.
Yeah, any other questions, please?
So Kishore, just want to confirm, like Jupyter is a command line tool which we need to install on Linux, right?
Jupyter is a server actually. You have to keep it running and then it will automatically open that page, and whatever Jupyter notebooks are available, it will display. So if you guys want, I will send you a Jupyter notebook, how to install and how to work with it, YouTube video.
Yeah, that would help. Yeah. Thank you.
Welcome. So Neil, is there any other question?
No, so far it's from my end, it's fine. Yes, participants, any other questions? We can take 1 or 2 questions probably.
Okay, so then see you next week. Oh, thank you.
Okay, thank you, Kishore.
Thank you.
Welcome.
Thanks, Neil.
Thank you,
Right.
Kishore.
Thank you, Dan.
Thank you, Neil.
Thank you.